The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to basically review for the Chapter 11 test. I'm going to start out by answering questions that people requested, and then I'll just ask if there's anything else you want to look at. So we're going to start with problem number 19, and this is from 11. Come on. There we go, 11.7. Okay, so let's see here, 11.7, number 19. Solve each equation, give the exact solution. Enter your answers as a comma-separated list. If there's no solution, enter no solution. All right, so we've got 3 to the 15x minus 1 power equals 243. Now, yesterday, we looked at 2 different ways of solving these kinds of problems. The first stuff that we looked at, if we could write them so that they had the same power, the same base, then we could go from there and set the exponents equal. If we couldn't do that, then we had to change it to a logarithmic equation, et cetera, et cetera. Well, it turns out that 243 is 3 times 81, which is 3 times 9 times 9, which is 3 times 3 times 3 times 3 times 3, which is 3 to the 5th power. So in other words, this one, I can do 3 to some power equals 3 to some power. So now I can take the exponents and set them equal to each other and then solve for x. I'm going to add 1 to both sides. 15x equals 6. Divide both sides by 15. X equals 6/15. Divide the top and the bottom both by 3. X equals 2/5. You all right with that? Antonia?
I'm saying yes, and I'm on mute. Yeah.
Okay. I thought maybe you were still right. All right. Now let's take a look. This was part A. Now let's take a look at part B. Here it says 3 to the 15x minus 1 equals 242. Well, if 243 is divisible by 3, 242 is not going to be divisible by 3. So now I'm going to have to use logs. So I'm going to have log base 3 of 242 equals 15x minus 1. Okay? You all right with that?
Yes.
All right. But I've got to solve for x. So I'm going to add 1 to both sides. So I've got 1 plus the log base 3 of 242 equals 15x. Okay. Now I've got to divide by 15. So x equals 1 plus the log base 3 of 242 all over 15. Okay. Now I've solved for x. Let's see here. It says give exact solution. So technically, this is an exact solution. What I want to do, can you see on the left side of the screen, can you see the answer that they have inside the big rectangle?
Yes.
I want to show you how they got that. But as far as I know, you should be able to enter what I've got right there. Because technically, to me, that, you've solved it. But what I'm going to do, I'm going to take that and go to the next page. So I've got 1 plus the log, let's see here, of, was it 242? Okay. All right. So the next thing I'm going to do is I'm going to rewrite this using the change of base formula. And I'm going to use log base n. Why? Because that's what they did. I could have used log base 10, but so this is going to be what? The natural log of 242 over the natural log of 3, the whole thing over 15. Okay? So far, so good?
Yes.
The next thing I'm going to do, I'm going to take the two terms in the numerator, and I'm going to combine them into a single fraction. So I've got 1 over 1 plus natural log of 242 over natural log of 3. Common denominator would be natural log of 3. So I'm going to take the 1 and multiply it by the natural log of 3 over the natural log of 3. So I get that. You following?
Yes.
Now, since these have the same denominator, I can combine them into a single fraction. Natural log of 3 plus natural log of 242 all over the natural log of 3 all over 15. All right with that.
Yes.
But that's equal to the natural log of 3 plus the natural log of 242 all over the natural log of 3 divided by 15. But that's equal to the natural log of 3 plus the natural log of 242 over the natural log of 3 times the reciprocal of 15, which is 1 over 15. Multiplying two fractions straight across, you get the natural log of 3 plus the natural log of 242 all over 15 times the natural log of 3. And that's the answer that they're showing. Now, I can't plug answers in to what I've got here on the screen because it's your thing there, but I would hope that you could actually put this in and they would accept it, but I don't know without actually being able to do it, which I can't put in there. So you could try that, see if it works. And if it doesn't, then, well, I guess they want it, simplified down to that, but that's how they get that. Okay.
Thank you.
Yeah. And that's kind of a mess to have to do all that, but well, sometimes math is messy, as we know. All right, number 21 coming up. So this is still 11.7, number 21. In 2 years, 40% of the radioactive element decays. Find its half-life. All right, so we're using the formula A equals A sub 0 times 2 to the negative T over H power, the half-life formula. In 2 years, so time is 2 years, 40% of the radioactive element decays. Find its half-life. So H is the unknown. What do we know? Well, we know its starting amount is A sub 0. The ending amount, if 40% decays, then 60% of the starting amount remains. So A sub 0 is just that, whatever the starting amount is, but A is 60% of the beginning amount. You all right with that?
Yep.
So now I've got 0.6 A sub 0 equals A sub 0 times 2 to the negative 2 over H power. Divide both sides by A sub 0. 0.6 equals 2 to the negative 2 over H power. Change it into a logarithmic equation. Log base 2 of 0.6 equals negative 2 over H. I'm trying to solve for H. H is in the denominator, so I'm going to multiply both sides by H, giving me H log base 2 of 0.6 equals negative 2. but I'm trying to get h by itself. So my next step is to divide both sides by log base 2 of 0.6. So I've got h equals -2 over log base 2 of 0.6. But I need to use the change of base formula. So I've got h equals -2 divided by the quantity log of 0.6 over log of 2. Let's see, this is 21. So on my calculator, I'm going to go -2 divided by parentheses log 0.6 close parentheses divided by log, oops, push the wrong button there. Hang on a second. I need to get rid of that. Okay. So divided by log of 2, close parentheses, and then close up this set. So I've got the little stuff inside, but I've got the whole denominator in parentheses. Okay.
Yes.
Equals, I'm getting 2.7138, blah, blah, blah. So round to one decimal place, 2.7 years. All right.
Yes.
Okay, 22 coming up. We good to go on?
Yes.
Alrighty. An isotope of thorium 227Th has a half-life of 18.4 days. How long will it take? So the unknown is the time for 80% of the sample to decompose. All right, so we don't know the beginning amount, but the ending amount, if 80% decomposes, 20% remains. Okay. So using the formula, A equals A sub 0, 2 to the negative T over H power, we get 0.2 A sub 0 equals A sub 0 times 2 to the negative T over 18.4. So far, so good?
Yes.
Divide both sides by A sub 0. 0.2 equals 2 to the negative T over 18.4 power. Rewrite it as a logarithmic equation. Log base 2 of 0.2 is negative T over 18.4. To get T by itself, I'm going to multiply both sides by negative 18.4. The 18.4s will get rid of the denominator. The negative times negative will make it a positive T. So now I've got T equals negative 18.4 log base 2 of 0.2. And I just switched them around and put T on the left instead of on the right when I went to the next step. Okay, using the change of base formula, negative 18.4 log of 0.2 divided by log of 2. That goes into the calculator. Negative 18.4 log of 0.2, close it up, divided by log of 2, close it up, equals. And I get 42.7234, et cetera, rounding to the nearest tenth, 42.7, and the units are in days. We know days because the half-life was given in units of days. So time is in days. Let me know when you're ready to go on.
I'm ready.
Okie dokies. 23. An isotope of lead 201 Pb has a half-life of 8.4 hours. So H is 8.4 hours. How many hours ago, so time is our unknown, was there 80% more of the substance? Okay, this one's kind of tricky because we're going into the past. So instead of saying we're starting with an amount, what's the end amount? They're saying, we know the end amount. How long ago was there 80% more in the past? Okay, so how's that going to work? Well, let's see here. We've got our formula. We know the half-life is 8.4 hours. We want to know the time. We need to figure out the relationship between A and A sub 0, okay? Now, in the previous problems, I've said A sub 0 equals A sub 0 and A equals some percent of A sub 0. But in this case, the ending amount is A. The beginning amount is A plus 80% of A, which would be 1.8 times A. So the beginning amount is all of A plus 80% of A. How are you doing?
Good.
Kind of tricky, huh?
Yes. I had to think about it first.
Yeah, do you see it now? You okay with it?
Yeah. Yeah.
So I'm going to have, let's see here. This was just determining this. So I'm going to have A equals 1.8 A 2 to the negative T over 8.4 power. I'm going to divide both sides by A, which is going to give me 1 equals 1.8 times 2. Actually, you know what? Hang on. I can do this all in one step. So let me go back and let's do this. I'm going to divide both sides by 1.8A. So on the right, I get that. On the left, I get 1 over 1.8, okay, because the A's would reduce down. So far, so good?
Yes.
I'm going to clean that up a little bit. I'm going to multiply this by 10 over 10. So I'm going to get 10 over 18, which reduces down to 5/9. And I suppose I could have left it as 1 over 1.8. It just bothered me as a fraction. But so now I've got this, okay?
Yes.
So now I'm going to get log base 2 of 5/9 equals negative T over 8.4. It's changing it into a logarithmic equation. I'm going to multiply both sides by negative 8.4. On the left side, I'm going to get negative 8.4. I'm going to go ahead and apply the change of base formula in this step. log of 5/9 divided by log of 2 equals t. Still with me?
Yes.
Calculator time. -8.4 log of 5 divided by 9, close it up, divided by log of 12, close it up. And I get 1.9869959, round it to one decimal place. Hang on.
I got 7.12317.
So you got the right answer and I didn't. So what did I do wrong? Oh, I see what I did wrong. This parentheses right here, I thought that was a 12 instead of a 2. My bad. Okay, so let's get rid of that. There we go, 7.123. Yeah, my sloppy writing is what killed me. So it's 7.1 hours, like you said. Okay,
Yes.
and then 25 was next. Sum of $5,000. Deposited in an account grows to $7,000. So that's the ending amount in 6 years. Assuming annual compounding, so it is not continuous, K is 1 once a year, what interest rate is being paid? Okay, now, since it is not being compounded continuously, we are going to use that formula, okay? If it was continuously, we'd use the A equals PE to the RT. But because it's assuming annual compounding, that's why we're using this formula, okay? So we know the end amount, that's $7,000. We know the starting amount, that's $5,000. 1 plus R, that's our unknown. K is 1. So then that's going to be raised to the 1 times 6 power because T is 6. Okay. All right. Now, this one's a little trickier than some of the others, so I can't just punch it all into my calculator right away. So I'm going to do some simplifying. R over 1 is just R. So inside I've got 1 plus R. Okay with that?
Yes.
The exponent, 1 times 6 is 6. So I've got that.
Yes.
However, that $5,000 out in front kind of messes this up because it's not part of the exponential expression. So we're going to get rid of it by dividing. We can't subtract it out. We've got to divide it out. So I get 7/5 equals 1 plus R to the 6th power.
Got it.
Okay, now if we change this to a logarithmic equation, let's see, what would that look like? We'd have log base 1 plus R of 7. That's not going to get us anywhere, but we could do this. We could take the 6th root of both sides. Okay. Now, doing that, because it's an even root, that's going to give us a plus or minus. So, and I'm going to switch sides here. I'm going to take this and put it on the left side. So the sixth root of 1 plus r to the sixth power is 1 plus r. On the other side, I've got plus or minus the sixth root of 7/5. Okay. So far, so good?
Yes.
But I'm trying to solve for r. So I've got to subtract 1 from both sides. So r equals -1 plus or minus the sixth root of 7/5. Okay.
Yes.
Now, I'm going to take this and I'm going to write that on the next page so I have lots of room to work with. So r equals -1. See, r equals -1 plus or minus the sixth root of 7/5. Okay. I've got two potential solutions. R equals -1 plus the sixth root of 7/5. R equals -1 minus the sixth root of 7/5. So far, so good?
Yes.
Now, to save some time, would you agree that the sixth root of 7/5 is going to be a positive number?
Yes.
So let's take a look at this one. If this is positive, you've got -1 minus a positive number, which is going to be even more negative, right?
Yeah.
So you're going to get an R that's a negative number. Well, since we started with $5,000 and we increased it to $7,000, the rate can't be negative, otherwise it would get smaller.
Correct.
Now, the reason I'm going through all that thinking is so I don't have to mess with calculating that. It probably would have been less time to calculate it, but just kind of see why I can throw that out. All right, now, how am I going to put this in my calculator? Do you remember how we have a button that's a square root button?
Yeah.
And then we have a button that's the X root button.
Yes.
So I want to put into my calculator -1 plus, then I'm going to put in a 6. Then I'm going to use the second function key of the caret key. That's that little sideways V. So I'm going to get to that. Parentheses 7 divided by 5, close parentheses equals. All right, so -1 plus 6, and then second caret key. So I've got -1 plus that. I'm going to put a left-hand parentheses and then go 7 divided by 5, close the parentheses, and push equals. I get R equals 0.0576800926. Okay.
Yes.
Now, that is the rate, but not expressed as a percent. That's expressed as a decimal. So to turn it into a percent, I would multiply it by 100%. So I get 5.7680926%. But it says to 2 decimal places. That's your second decimal place. The 8 would round up. So the rate would be 5.77%. Boy, that's a messy problem, isn't it?
Yes, it is.
It's like everything we've ever learned since kindergarten in one problem. Ah! All right, that's all the questions that you had emailed me.
Yeah.
It's just you and me. So what else would you like to look at? Do you have anything else you want to look at?
Yes, the chapter 11 review.
Okay, give me just a minute here. I'm gonna change the screen. And then let's go to the chapter 11 review. Yeah. Okay. So, do you want to start with number one, or where do you want to start?
Yes, I want to get more practice on that, on those.
Okay, so this is the chapter 11 review. And this is number one. It says, let f of x equal x squared plus 1 and g of x equal 3x plus 1. Find the following function value. F composed with g of -1. Well, f composed with g of -1 is equal to f of g of -1. All right. So
Yes.
then what is g of -1? G of -1 is 3 times -1 plus 1, which is -3 plus 1, which is -2. Since g of -1 equals -2, we're going to take -2 and substitute it in the place of g of -1. So now we have f of -2. So far, so good.
Yes.
But that's going to go up here. So that's going to be -2 the quantity squared plus 1, which is 4 plus 1, which is 5. So f composed with g of -1 equals 5.
Okay, got it.
What next?
Um, can we do a few of those ones, like number 4?
Okay. You betcha. Number 4. Okay, let f of x equal x squared plus 3 and g of x equal 4x plus 5. Find the following function value. G composed with f of x. G composed with f of x equals g of f of x. What is f of x? It's x squared plus 3. So that's going to go in the place of f of x. So that's g of x squared plus 3. So far, so good.
Yes.
What is g of x squared plus 3? Well, g of x squared plus 3 is 4 times x squared plus 3 plus 5, which is 4x squared plus 12 plus 5, which is 4x squared plus 17. My x is mutating into a y. Okay. Let me know when you're ready to go on and what you want next, and that's where
Okay,
we'll go.
I'm ready. Can we do number 5?
Sure. Determine whether the function is 1-to-1. All right. Well, let's see here. f of x equals 1/7 x minus 9. Isn't that a linear equation in slope-intercept form?
Yes.
So the slope is 1/7 and the y-intercept is -9. So on a graph, it would look like this, and then you'd go up 1 and over 7. So you'd have this really small slope. So it looks something like that, roughly.
Yeah.
Does that pass the vertical line test? Do you remember what that is?
Yeah.
Does it pass the vertical line test? Yes.
No. Yeah,
Yeah, it does,
it
'cause
does. It does.
it doesn't cut through it twice with any line.
Yeah.
Besides, it's a function, so it has to pass the vertical line test. Does it pass the horizontal line test?
Yes.
So it's a 1-to-1.
Okay.
All righty. Okay, next.
Can we do, what is it? Number 8.
All righty. Use the table of values of the 1-to-1 function f to complete the table of values for f inverse. Okay. Recall this, something I said several times in the past. When you have a 1-to-1 function, it has its domain and its range. Its inverse function also has domain and range, but the domain of the original function is the range of the inverse, and the range of the original is the domain of the inverse. So what we get is the domain of one is the range of the other. The range of one is the domain of the other.
Oh, yeah.
Okay? So
Yeah.
basically the table values just switch.
Okay, got it.
Excellent.
Can we
What's
practice
up next?
with the graphemes, like
Okay.
number 9?
Given the graph of function f, graph f inverse on the same coordinate axes, label the axis of symmetry. Okay. Let's see here. What I'm going to do is I'm going to go back here and use a grid that's not quite big enough, but I think it'll get the point across. Okay. So I'm not going to graph the entire thing. I'm just going to graph it between -6 and 6. So we've got this, and then this, and 1, 4, and 6, 6. So there's the picture that we have to start with. So that's the graph of F. Okay.
Yeah.
Now, the axis of symmetry is basically y equals x. So let me put that on there. Recall several things about functions and their inverses. If you've got a set of ordered pairs for a function, if you switch the x and y's around, you get sets of ordered pairs for its inverse. So for instance, this is -3, 0. So the point 0, -3 would be on the inverse. You following that?
Yes.
This is -2, 2. So the point 2, -2 would be on the inverse. This is 1, 4. So the point 4, 1 would be on the inverse. This is 6, 6. So 6, 6 would be on the inverse. So your graph looks like that. Also, this graph is symmetric with that graph about the line y = x. So I could have done it that way. I could have said, well, I've got this point. So if we come across here, I'm going to have this point. I've got this point. So if we come across here, I'm going to have that point. You see what I'm saying?
Yeah.
All right. So which of these looks like that? Well, let's see here.
It's not that one.
Well,
Because doesn't.
okay.
It looks like, yeah,
Is it that one?
that one. It looks, yeah.
Yeah, we can obviously eliminate those two. This one I kind of had to think about a bit. But yeah, so here's the answer.
Okay.
All righty.
Yeah.
So whenever you're ready, we'll go on.
I'm ready. Number 14.
14. Use composition to show that f of x equals 4 minus 7x and f inverse of x equals negative that, or inverse functions. Okay, so simplify your answer completely. Okay, so basically we're going to compose them in both directions. And this whole fill in the blank thing again, I know is kind of confusing. So let's just, I'll do the problem and then I'll come back and talk about what goes where and why. All right.
Okay.
So what is this, number 14? We've got f of x equals 4 minus 7x. F inverse of x equals negative the quantity x minus 4 over 7. And we want to show that the inverses, or that the composition in both directions is true. So we're going to start with f composed with f inverse of x. Okay. That's equal to f of f inverse of x. That's the given. That's because that's like your first step, right?
Yeah.
That's equal to f of negative the quantity x minus 4 over 7.
Yeah.
That's equal to, what are we going to do? We're going to take that and put it up there. So that's equal to 4 minus 7 times the quantity negative x minus 4 over 7, which is equal to 4. Now let's see, what could I do here? The 7s could cross out and the minus times minus is plus x minus 4, which is equal to x. All right.
Yeah.
Now, I'm going to change colors of the ink and hopefully this will help things. Let's look at what they're asking for and what I've got. The first thing they want to know from this first step here, what's the next step? Well, it's f of
There it
that.
is.
Now, if you look in the box over here, what I have is different from what they've got. And here's what they did. If we take this and we think of it as the negative sign being applied to just the numerator, and then we distribute it, we get that, which we could then rewrite like that. So what I've got here in red is correct. I just didn't go through the simplification steps that they did. So putting this in there still should be correct, but be careful. You don't want to write it like that. You'd either have to write it with the negative sign out to the left or like that. Or you could go through these simplification steps that they did, but I just didn't bother to do that in that step, okay?
Okay.
Then the next step, again, I would put that in the box. They put that in the box because they, again, made the simplification, okay?
Yeah.
Then the next box, it's 4 plus whatever,
Mhm.
what I've got, and then finally
Equals 6.
equals X. Yeah. All right with that?
Yes.
So do you want me to do the second half or are you okay?
No, I think I'm okay with that one.
All right. All right. Excellent.
Can you send us the formulas, the sheet?
Absolutely. Just a second here. Okay. Let's see, let's change it back to black ink instead of red because I think the black probably shows up better. So what formulas have we had? Well, we had the compound interest formula. Okay, so you would use that when something's being compounded not continuously. So annually, semi-annually, quarterly, monthly, 12, okay. Then we've had this formula. That's when there is continuous growth or continuous decay, or the interest is compounded continuously. We had the formula when you are doubling a population, doubling some money, whatever, that's compounding continuously. And then we have the half-life formula. A sub 0 times 2 to the negative t over h power. I think, oh, yes, we also have the change of base formula. Let's see, log base b of, I forget what they use, but I'll just use x. So that's log base a of x over log base a of b. So you could write it log base 10, or you could write it log base e. I think, yeah, I think those are the, oh, okay. There's one other, that's changing from exponential to logarithmic form and logarithmic form to exponential form. So y equals b to the x becomes log base b of y equals x. All right?
Yeah.
All right. Well, it's time to go. So tomorrow there will be no class meeting. I will be back today at 1:15 with an office hour. Tomorrow I'll be back at 1:15 with an office hour, but tomorrow basically no class meeting at 11:30. Take your test, have it done by 11:59 p.m. tomorrow night. And then I will be back on Monday during regular class time, as well as Tuesday during regular class time, primarily to answer questions that people have, want to review things for the final. I'm not going to just cram everything super fast and try and go through everything. So I would just say over the weekend, maybe go back through and see what things you still, want to see again. And we'll just spend that time reviewing. Whoever shows up, I'll just answer questions for the hour, Monday and Tuesday, and then Wednesday, you'll take your final. All right. So unless you show up at the office hour, I won't see you till Monday. Hope you do
Yeah.
well in the test coming up.
Thank
And
you.
let me find my mouse here and I'll stop the recording.